Mobile apps rely on system and sensor values like battery, time, motion, and step counts to decide what features to show or which behaviors to trigger. Researchers and developers need a reproducible way to manipulate these values to test app behavior, reproduce bugs, and evaluate privacy risks. PriviSense is an on-device framework that provides a reproducible workflow for spoofing Android sensor and system values directly on a rooted phone. It integrates Frida-based hooks for multiple sensor APIs, battery states, and system identifiers, enabling controlled manipulation across real apps in real time. In this demo, I start the Frida server inside Termux, attach it to a sensor app, and load our spoof.js script. This script intercepts calls to sensor and system APIs and replaces them with controlled values. Everything runs on the phone itself. No external machine is needed. Here, the spoofed values are active. The battery is fixed at 5%. Temperature is locked at 0.5 degrees Celsius. Charging is always true, and the system model and Android version have been replaced. Even the system time is shifted. These values now appear consistently across apps that query them. As we switch to another sensor viewer, you can see the same injected values persist. The app reports the spoofed readings identically. Opening a second app, the battery and motion values remain spoofed, confirming consistent behavior across apps. On this third app, note the step counter and gyroscope still show the controlled values we injected earlier. On the fourth app, the spoofed readings remain visible. This demonstrates persistence across app boundaries. And on this fifth app, the spoofed readings appear once again. Seeing the same fixed values across all these apps confirms that the spoofing is reliable and system-wide. The point is not just that the values change, but that they can be changed in a controlled and repeatable way. For software testing, PriviSense lets developers simulate states they normally cannot reach, like forcing a fitness app into cycling versus running mode, or testing how low battery warnings appear without draining the device. For privacy research, PriviSense shows why values like step counts are highly sensitive. By spoofing a step counter, apps report physical activity even when the user is standing still. Beyond fitness, PriviSense can also explore how apps respond to contextual triggers, such as car dashboards, crash or fall detection, or emergency SOS features. These examples highlight how spoofing becomes a method for uncovering both functionality and risk. Finally, I disable spoofing and restore the device. The original, non-spoofed sensor and system values are visible again, confirming safe return to normal. This concludes the demonstration of PriviSense. All spoofing was performed locally on a rooted test device. To prevent misuse, the full code will not be released publicly, but can be shared responsibly with verified researchers upon request. Thank you for your attention.